Hello friends, welcome back for another deep learning project, fake news detection using bidirectional LSTM. Here we will detect the news, as many real world news are now generated through AI or created by users and that are really fake or real. To ensure that, we will build a model which will detect news either as real or fake, and we will be doing that with bidirectional LSTM. So for that we are using a dataset available in Kaggle, that is pre-processed well fake news dataset. Here we have a CSV file which we will be using for this project, and for accelerating purpose I am using GPU T4x2 and having the preference to the original environment. So before proceeding, make sure you have the accelerator GPU T4x2 and the input data pre-processed well fake news dataset in your input section. So at first I have imported the required libraries like Keras, Keras Hub, NumPy, TensorFlow, Pandas and scikit-learn. Keras Hub, TensorFlow are for building the model, and NumPy is for numerical calculations. Pandas is to manipulate the data, and scikit-learn is to split the data. So we are using Keras Hub library because the Keras Hub library provides us a many useful utilities like layers, tokenizers, preprocessors, losses, metrics, etc. And for building natural language processing projects, Keras Hub is a very useful library through which we can build advanced NLP projects. So let's import these libraries. After that, I have created a GPU strategy using the mirrored strategy method. This strategy will be used during model instantiation and model compilation so that we can use the accelerator GPU during training, and with the attribute number of replicas in sync we will get the number of cores or machines or GPUs available in the strategy. So let's wait for some time because libraries are getting imported. Yes, all libraries are successfully imported. Let's create this strategy and see the number of cores. Yeah, we have only 2 GPUs available with us, and now we will prepare our data. So we have a data set in the file path available here, and which is copied from this location. You can go to the input section and copy the file path from this button and you can paste over here. Using the read CSV method, I am loading the CSV file to a data frame, and from the data frame I am only using two columns. One is text column, another is a level column. Here we will find two levels. One is 1, another one is 0. 1 for fake news, 0 for real news. And text column will contain different news items. And after that we have used head method to see the first 5 rows of the data frame. Let's run this. So you can see we have only two columns, text and level, and here the first news is no comment is expected from Barack Obama members ... that means it's a long news. And we have the level 1, that means it is a fake news. So likewise we have 5 rows of news. And let's have the value counts of the level column. It will return the number of ones and number of zeros in the level column, which will show us the balanced proportionality of the levels. Let's run this. So you can see we have 36,509 levels as 1 and 35,028 levels as 0. These levels indicating that the data set is quite balanced and very little imbalanced, so we don't need to change it to make it balanced. After that, using the train test split method, I am splitting the data set into train data and validation data, with 20% of data reserving to test part or validation part. And we have argument random state equals to 42, so that whenever we redo the splitting, the data will be splitted again as the previous one. After splitting, we are checking the shape of X train and Y train, so that we can see the shapes of X train and Y train, which should be equal. Let's run. So you can see we have 57,229 rows for X train and 57,229 rows for Y train. After that, from the validation data X test and Y test, I am splitting the data into validation and also test purpose, with 50% reservation for each, and having the random state equals to 42, and checking the shape of validation data. So let's run this. So you can see we have 7,154 rows in validation data. After this, I want to create the TensorFlow dataset from these datasets or data frames. So to create the TensorFlow dataset, I have built or created a makeDS named function or method, which will take mainly two arguments, X and Y, which are data frames, X for news text and Y for levels, and another argument is train, which is by default false. When the x and y are provided to the MakeDS method, using the from tensor slices, it will create or generate a data set using xy, and if the each train argument is true, then the dataset will be shuffled, and if not, then the dataset will if not, then the dataset will not be shuffled. After passing that conditional statement, we will return the dataset by batching the dataset with batch size of 1024 elements. So to create train dataset, we will pass xtrain ytrain to MakeDS with the each train equal to true mask or argument. Then for testDS and validation DS, we will pass xtest ytest to MakeDS for test dataset and xval yval to MakeDS for validation dataset. After that, using the wordpiece method available in Keras hub, we will convert the text into integers. So for that, in Keras hub we have wordpiece tokenizer, which will tokenize the text data into integer formats. So that's why we are using the Keras hub library for this pre-processing step, and as we know, we can't feed our model the string data. That's why we need to convert the string data to integer format. So for that, wordpiece tokenizer, we need a vocabulary so that we can compute the indices of the text or words available in the vocabulary. And we have a beautiful method which will compute the vocabulary for the wordpiece tokenizer, and that is nothing but compute wordpiece vocabulary, which is available in the Keras hub library in the module tokenizers. So for computing the vocabulary, I have created a method train wordpiece where I will pass a data set, and from the data set we will take out only texts, not the labels, and before taking out the text we will unbatch the data set, and then using the compute wordpiece vocabulary method we will generate the vocabulary and will be saved that in the vocab variable. Then for that compute wordpiece vocabulary method, we need to pass certain arguments like the data, and here in our case we have this wordpiece dataset, and which is batched with 1000 elements and prefetched with 2. Then we are extracting only 20,000 elements from the corpus, so our vocabulary size will be 20,000 only. Then we are converting all the words or text into lowercase, and we have 2 reserved tokens. One is for padding, another one is for unknown tokens. So these are two reserved tokens that we are using. By default it will take 5 reserved tokens, but we are only using these 2 tokens for our case. And after generating the vocabulary, we are returning from the method. So let's generate the vocabulary which we will use for training our word piece. It will take some time to generate 20,000 words or sub words. So wait a while. It may take around 1 minute to generate all the 20,000 vocabularies. Yes, the word piece or vocabulary is computed by the compute word piece vocabulary method. So let's check the length of the vocab size returned by the compute word vocabulary piece, because we computed for 20,000, that is the maximum limit. Let's see. So here you can see it has provided us 19,439 important vocabularies. So using that vocab, we will generate the tokens of sequence length 1000 with the method word piece tokenizer available in Keras hub. So let's run this, and using this tokenizer we will pre-process our data, which is done in this part. So we will be using a map method, and inside the map method we will have a lambda method, a lambda function, which will take 2 parameters, text and label. For text we will tokenize and we will pass the label along with the tokenized text, and we have an argument number of parallel calls equal to tf dot data dot autotune, which will allow TensorFlow to decide how many parallel threads to use when applying the map, and it will improve the CPU utilization. And also we have extended prefetch with the argument tf.data.autotune. This will preload the next batch in the background while the model is training, which reduces the data loading bottlenecks. So let's run. So all new train DS, new well DS and new test DS are created successfully. Let's check the shape of the text and labels from a batch of new train DS. So in each batch we are having 1024 elements, and the length of sequence is 1000, and we have 1024 labels in each batch. And the next part is to build the model, and as we are using bidirectional LSTM, it does not requires any positional embedding, because it knows the positions of the word orders, so we don't need to do positional embedding. So we are creating a simple bidirectional model. First of all, we are taking the inputs of sequence length 1000, which is of d type integer 32. Then we are embedding the inputs from 1000 dimension to 128. Then using the bidirectional LSTM with 64 unit of neurons, we are generating the outputs. Then again we are passing that output to another bidirectional LSTM with 64 units, and the difference is that in the first bidirectional LSTM we have argument return sequences equals to true, which will return sequences, but in the case it won't return sequences. And then using a dense layer as a top layer for classifying the news either as fake or real. For that we are taking one unit, then having sigmoid activation function, and using these things we are building a functional model and returning that model from the method. Let's create the model. So model is created successfully. Then we will compile the model under the scope of the strategy, and inside the strategy we will instantiate the model, then compile the model with optimizer Adam, loss as binary cross entropy, and accuracy as matrix. Let's run this. Then I have defined a callback model checkpoints for saving the model checkpoints in the file path model underscore cp.keras. Then here we are monitoring validation accuracy and mode equals to max, and using the new train ds for training the model and validating the model with new values, and we are having 5 epochs. Let's run this. After the 5th epoch we got training accuracy of 94% and validation accuracy of 83%. So let's evaluate the model with test data. So it is 84% of accuracy. Let's take out the best model from the checkpoints and evaluate that with the test data. So this model is resulting 94% accuracy. So after that we are building an inference model where we will provide string inputs, then we will tokenize it with tokenizer, then pass that tokenized input to the model and it will return us the output. So we are doing that and building a functional model with the inputs and outputs. Let's run this. And after building the inference model we need to compile it. So let's compile it under the strategy. After that I am using the inference model for predicting whether this news is fake or real. So the news is the White House has denied a report which claimed Trump is looking to replace Defense Secretary Pete Hegseth amid a leak scandal. Press Secretary Caroline Leavitt called the story total fake news, while Trump reaffirmed his support for Hegseth, blaming disgruntled employees for the controversy. So it is a fake news collected from the Google and passing that to the inference model, and if the prediction is greater than 0.5 we are printing fake news, else we are printing real news. So let's run this. It is a fake news, and you can check this with replacing the text over here when you will do that. And sorry for the inconvenience that I am not going to do more examples here or show the more examples here. Just I am saving the inference model and also I am saving the model. Let's delete this line for now. Let's save the inference model with this, and you can use this model by downloading from the output section. for your real-time projects. So thank you for watching this video. Thanks a lot.